is the most unique feature, I would say, AI capability, artificial intelligence stuffs. So when it comes to artificial intelligence, right, I have been in this industry, so where I was not knowing anything what is artificial intelligence and what is a subset in that. One of the subset is machine learning. Um, was under the impression, at least in the beginning, artificial intelligence is only specific to a set of people who has a PhD degree, has a degree in mathematics and statistics. Only they can write a machine learning stuff or a AI component is what many of us were thinking. But Google braked it. They tried to democratize AI, make it available to everybody. Was the one which Google tried to do it, and they have doing it even today. So let me just try to explain this slide, this pyramid or triangle. Let's assume you have an insurance app, a mobile app, or a website. Now there's one car owner who meets up with an accident and the car is damaged. This user wants to claim the insurance. What he will do, he will open the app, he will enter all the details, he or she will enter all the details, the car number, the registration number, driving license, all those information. Definitely there's going to be one column which is going to ask, please upload the image of this damaged car so that we can process it. Now if this app is not AI driven, meaning it is not having that intelligence, this person can also upload a bike's photo. The application will get processed. Once it has been reviewed by an agent, a call center agent, the agent will call and say, sir or madam, you have not uploaded the right image, please upload the right image. The reason why this can happen is because those apps are not AI driven. Now if I want to do the same thing, make it more effective, have a AI driven app, I can use something called as ML APIs, predefined APIs. And for using this, you don't need to be having a PhD degree. If you know how to call a endpoint, a URL, that's all good enough. So let me just show you a small demonstration on this part. So to give you a feel, and this website, treat this as your insurance app. So let me just open it. This is an AI capability called as Vision API. So let me just wait for the screen to come up. Okay, the screen has come up. For a minute, please assume this is your insurance app, and this is the option to drag and drop the image, the damaged car image. Now let me click on this, and what I will do is I'm not going to upload a car photo, but rather I'm going to upload a bike's photo. Okay, so I'm going to upload this bike's photo, which is slightly damaged if I'm not wrong. The front end is the front part is slightly damaged. A boat. Hope I am correct. That's the most difficult part, that captcha. Okay, so when I upload this kind of a stuff, right, if there's a machine learning running, it's going to quickly say it's a motorcycle with 97% accuracy. Now this kind of a validation, if that insurance app had done right, it would have blocked the user from uploading a two-wheeler photo and would have prompted him to upload a right car photo. So you could have reduced that call center person's effort calling him, covering it, all those things. So now a normal insurance app, you have converted that into a AI driven app by just calling what? Just calling this URL, folks. vision.googleapis.com/version v1/images and passing this image. Who can do this? A web developer can do it very easily. So now you, as a cloud architect, you are proposing for this kind of a use case, why don't we use something called as Vision API, which Google provides. Now how do I do that? Now assume the developer has used this API and built it by just calling it. We are not asking him to write some machine learning code. He may be a person who is comfortable with writing some Python code for web application. So he's just going to call this URL endpoint and pass this image. And if the output is saying motorcycle, ask him to upload a new image. Now, if he has done that implementation, let's upload a new photo, which is a car. Now I have uploaded a car to this AI, which is really a damaged car. It shows car 91% it is saying. Now it's just a small condition, right? He needs to check, is it equal to car? Fine, process the claim. That's it. So I can make this normal AI, normal application into AI driven by just calling this API, and I don't need to have any PhD degree. If I know how to call this via this URL, which a developer can do it very easily, you're done. So that is the first part. So, and the reason for showing this is what it has done, it has democratized it. So if you're a developer, you just call this API and you can turn your normal app into an AI based app. So that's the first set of people where Google is helping them. Now, assume you cannot write a code. You are basically coming from a machine, from a business perspective, but you can get some data. For example, if I just go back, so this API, right, or this capability gave you that it is car, but what it did not give you, is there any information which it did not give, folks, which a human eye can easily say? We humans can easily say, rather than saying it is a car, we will say it is a damaged car, right? But if you see, this API did not give that anything. The front portion is, or the side portion is damaged. It cannot give it, because that's the limitation of this API or this machine learning API. Now, if you have a requirement like this, when I upload a car photo, it should say whether it is damaged or not damaged. So if you want such kind of a stuff and you don't want to write a single line of code, then you can use something called as AutoML. So you can use something called as AutoML. So this is for developers who can call an endpoint. AutoML is for business users who don't want to write a single line of code. Business user, but you should have a data. The data has to be provided, like 100 images of car which is damaged, 100 images of cars which is normal. Just upload it into a service. It's going to train and it's going to give you that prediction. Now, this is for business users. Now, if you are a database person who can write SQL statements easily and you want to do some machine learning, you have a capability called as, for SQL people, called as BigQuery ML. So usually when you think of machine learning, there's one language which always pops up to everybody's mind. It is Python. It is made very popular. But if you don't know Python, but you are coming from a database background, you want to do machine learning, you can do it with BigQuery ML, which is Google's warehouse, where you can have your machine learning built in a SQL statement. Now you are not learning something new. You know you are an expert in SQL. For a SQL developer, we are providing an option there to write machine learning stuffs. Now, if there is some specific requirement, now developer over, business users over, SQL over. Now let's think of a specific use case like uh, semiconductor manufacturing industry, and they're manufacturing those semiconductors. There's definitely going to be those chips, right? The VLSI chips. And assume the requirement is one of the pin is broken. Now you want to find out whether the pin is broken or not. Very, very niche requirement, uh, which nobody can do except a data scientist. So if you are a data scientist, Google provides you an option called as ML engine. Now this is for hardcore data scientists where they can write some complex codes, all those things, And for that code to run, they are going to provide an infrastructure called as Cloud ML Engine. Awesome. Now you have given for different set of people, data scientist, SQL developer, business user, developer. Now all good. Now how do I operationalize it? So machine learning, how do I operationalize this entire part? So that's where you're going to use something called as Kubeflow, which is again based on Kubernetes. Now, many people would have heard of DevOps, data ops, all those kind of stuffs. But what you not have heard is something called as ML ops. If you have heard it, that's good. ML ops, machine learning operations. How do you operationalize it? Now, in next 1 year or 2 year, this is going to become like a norm. Machine learning is already becoming like commodity, like how everybody has a smartphone these days. uh, Machine learning is going to become commodity. Every app is going to have machine learning, but operationalizing it, maintaining it is going to be very, very important. That is where this ML ops is going to be really handy. So, and Google is really excelling in this part, ML ops. So if machine learning becomes very popular and this is a mandatory thing, then again GCP is going to come very, very handy. Kubeflow, for your information, is open source based, but Google also provides their own version of it, so you can do machine learning ops easily there. So this is another valid reason where Google can become number one, because you provide that capability for everybody easily to operationalize it and manage it. And the last one is on virtual machines. This is for beginners. So if you don't know anything about machine learning, so you want to learn Python from the scratch, and you don't want to spend time in installing Python and configuring all those things, you just search for something called as deep learning VMs, where they provide you a packaged virtual machine. You just log in and start writing your code, learn your code, and do it. So for every set of categories of people, Google provides machine learning capabilities. So that is the reason why usually you would have heard this term in many of the videos from Googlers itself. Google tries to democratize AI, so make it available for everybody. So these are four valid reasons why one should go with GCP, and these are also couple of reasons are really valid, which can make Google become the number one cloud provider in the next